the entire screen. Whoa. So it seems I will have to. Okay. Yeah. Okay. Can you see my screen? Can you see my screen?
Yes.
All right. Okay. Okay. That was nice. Let's do it like this. We're going to be starting with slides just to uh, give an introduction of what we're actually going to do today. Then we'll go to the actual coding, right? So what we're doing today is building your first dapp. During the course of this during the course of the lecture, if you have any question, just say it. Like, you can interrupt me and speak up, right? Because I'll be able to hear you if you speak up. So if you have any question during the course of the lesson, just interrupt me and speak up, and I will answer. All right. So we're going to be talking about building your first dapp today. So this is for the Web3 track of the blockchain or the bootcamp. My name is Nonse Febo. We all know today's date, so that's one issue. All right. So building your first dapp. So what is a dapp? That's the first question. What is a dapp? So a dapp is an application that communicates with a decentralized platform like a blockchain. Right. So that's what a dapp is. It's not difficult. So a dapp, the full meaning of a dapp is a decentralized application. That's the full name, decentralized application. So the D stands for decentralized. Now, it's said to be an application that communicates with a decentralized platform, any sufficiently decentralized platform. And a good example of a decentralized platform is a blockchain. There are other platforms that are said to be decentralized too, but a good example and the one that is mostly used today is the blockchain. So any app that you have on your phone that interacts with a blockchain can be said to be a decentralized application. That is a dapp, right? So it's as simple as that. So let's look at the difference between a dapp and the traditional applications. So moving forward, all right. So if you look here, this shows the difference between a traditional application and a decentralized application. Now, for the normal traditional application that we all know, right, that you should already know, right, the way it works is we have a client, which can be your phone, your laptop, or whatever. So there's a server also. Now let's say you're on Facebook on this client. Let's say you're on Facebook on this client. Let's say on your phone you're on Facebook. You can send what you are doing when you are interacting with Facebook, when you are commenting, when you are posting, right? What you are doing is you are communicating with a server hosted with Facebook, right? So there's a server that is hosted with Facebook that you're communicating with. The server is basically still a computer. So what happens is, let's say you want to make a post, you send a request that, okay, you tell the Facebook server, this server, that you want to make a post. You tell the server that you want to make a post. So that's your request, and the server then, so when you're sending your request for the post, you have already sent the details of your post, of what you actually want to post, or the picture and the text, right? You already sent it. So now the Facebook server sends a response back to your phone or your laptop. So this is the response. You send a request and it sends a response back to your phone or your laptop, telling you, okay, your request has been received and it has been handled, right? So either it was a success or a failure. This response tells you. So at the end of the day, when you want to make a post, you send a request. Now the response at the end of the day, which you usually get when you're using Facebook, is that it tells you your post has been successfully uploaded, right? So the server helps to upload your post and make it available on the Facebook platform. So that's it about traditional applications. Now the difference between a traditional application and a dapp, which is a decentralized application, is that this client here, right? This client right here is actually communicating with a blockchain. Alright, is actually communicating with a blockchain. Sorry, I need to hide this. So this client here, right, is actually communicating with a blockchain. I need this to go away. Yes. So this client is actually communicating with a blockchain. So this is the blockchain and this is the client. So instead, like you have noticed, like I have mentioned with the traditional application, the request goes to a server, right? For instance, you're using Facebook, it goes to the Facebook server. But for this one now, the request goes to a blockchain. That's why the decentralized application. The request goes to a blockchain, and the response comes back to your device that you're using in running that decentralized application, that dapp, right? So for instance, I don't know if you're familiar with Uniswap, which is very popular. If you're using Uniswap and it's running on your phone, you are not interacting with any centralized server that is either Facebook, Google, or whatever. What you are doing is you're interacting with a blockchain. And for Uniswap example, that blockchain is called the Ethereum blockchain. So you're interacting with the Ethereum blockchain. So that what you are doing, basically you are sending a request to the Ethereum blockchain and it's sending you a response. So because this application runs on a decentralized platform, because this application runs on a decentralized platform, of which is the blockchain for this particular instance, that's why it's called a decentralized application, right? So what we're going to be doing today is going to be doing this. It's going to process any request that we have on our system. So it's going to send any request that we have on our system to the blockchain, and the blockchain is going to send back a response. So that's what a decentralized application is all about, and I think that's mostly it. So let's move on to see what we need in building a decentralized application. So for the clients, like I already mentioned during the start of this particular bootcamp, for the client you will need Web2 technologies like HTML, CSS, and JavaScript. Your regular Web2 technologies are what you use in building a client. So you are fine if you already know Web2, right? Now, if you come back here, this blockchain entity, what the client actually uses in communicating with this blockchain entity is called a smart contract, right? It's called a smart contract. So the smart contracts are like programs that run on this blockchain, right? So there are programs that run on this blockchain. The same way the Uniswap website is running on your phone. In the same way, there's another program that runs on this particular blockchain. So what is happening is your client, which can be your phone, is communicating with that blockchain, and on that it's actually communicating with a smart contract on that blockchain. So that's what actually happens. Now let's see what to use in building smart contracts. So for clients it's Web2. For smart contracts on the blockchain, they are built using Solidity, Rust, or any other language that's supported by a smart contract enabled blockchain. There are a lot of smart contract enabled blockchains that exist today, right? So there's Solana, there's Polkadot, there are a lot of them, right? All those blockchains use their own languages. So the most popular one right now is Solidity, which we are going to be using, right? So that's what we are going to be using. Now this smart contract will be built using Solidity, and the client will be using HTML, CSS, and JavaScript. So it's as simple as that. So does anybody have any questions, or can you guys hear me well?
Yes, we can hear you.
Okay. So are there any questions? No question. Okay. So let's dive into the code. So let's code this thing. Now, so this is what we're going to be building. We're going to be building this. So we'll do the HTML, CSS, and JavaScript, and we'll also write the smart contract using Solidity. So we're going to be building this. So this is going to be our end product. Now, I don't know if have you guys started using Web3 DAO? If anyone has started using Web3 DAO here, can you just signify by like raising your hand? Like, I want to see if anyone has started using it. Whose hand is up? Someone's hand up. Okay, Manuel and Oladani. Okay, that's fine. So if you have not started yet, and you want to go into Web3, you should start using Web3 DAO. Right, you start using Web3 DAO. The website is learnweb3.io. Right, so that's the website. Learnweb3.io is the website. I think I can send it here. Learnweb3.io. So that's the website. You can start learning about Web3 there, and you learn about Solidity. You learn about how to build UIs, that is front end, that interact with smart contracts, which is what we're going to be doing here today. So for today we'll be doing let let me go to the starting of. Let me start here. Yes, so this is the Learn Web3 DAO website, right? So this is the website, and today we are going to be following this freshman course. We're going to be doing this. This is build your first dapp. So we're going to be building our first dapp, right? So what I've done is that I've already gone through everything here. I've gone through everything here, and I'm going to be building it. But I want you to just know that whatever I'm doing is what has already been done here. So you can come back here for a refresher, and they have a video that also explains it. But I'm here with you just to answer any of your questions that you might have when we're building this stuff. So let's dive in. I already have the code here, but we'll be clearing everything. Just to okay. So everything we have cleared everything now. So I've already mentioned before. If you have any question while I'm writing the code or I'm explaining, you can just interrupt me and mention whatever you have. Just say it, like I'm ready to listen. If you have any question, just say it. I'm also ready to answer. Right? I don't know. Am I too fast? Can you guys hear me, or am I too fast?
You are not too fast, sir.
Okay. That's nice. So this 6:22. Okay, I hope we have enough time for this. Okay, so let's dive in. So like I already mentioned, we're going to be building a dapp basically. Right, we're going to be building a dapp. So a dapp, I like already said, has a client. Where is the yes? So a dapp has a client. So this is a dapp. It has a client and interacts with smart contracts on this blockchain. So we'll first start with building the client, then we'll come to smart contracts. And we already mentioned that the client is built using HTML, CSS, and JavaScript. So let's start with the client. So this is VS Code. This is VS Code. This is an IDE, right? Integrated Development Environment. So you should already be familiar with VS Code. And I'll create a HTML file now. So this is going to be index.html, right? And I'm going to start building the client right here. So for this client, it's going to be something called a mood app, right? A mood application where you can save, right? You can save your current mood, and you can update your current mood. So that's what we're going to be building. Basically, it's as simple as that. So for VS Code, I don't know if you're not familiar with VS Code. If you type exclamation mark, it will give you an auto completion of a sample HTML document. That's if you use exclamation mark, if you type exclamation mark. So this is my sample HTML document. I'm just going to update this to my first dapp. So that's it. That's the title. Now for our dapp, I'm going to give it a H1. So this is going to be like the main heading. This is going to be my first dapp, H1, and underneath we're going to have let's just call it my mood. So it will show our current mood, my mood, right? So whatever mood we have is going to be here. So that means this place can be grumpy, happy, sad, or whatever, right? So but the main thing is whatever is here, we're going to be getting it from a smart contract on the blockchain. So that's a H2. Now for the mood, right? We're supposed to be able to enter our current mood. So that means we need an input element. So because we're supposed to be able to enter our current mood. So the text is going to be it's going to be type text, and let me give it a label. I think this is going to be for the ID. So it's going to be for this ID. So this is going to be mode, and I'll just say mode here, right? So this is it. So this is the label, and this is an input box. So underneath we're going to have a button. It's like I almost forgot how to spell button just now. So I'm going to have a button set mode, and button get mode. So these two buttons are going to, anytime I click a button, it's going to get my current mode from a smart contract on the blockchain. And anytime I click this other one here, it's going to set my current mode, and any mode I set will come here, right? It will update right here to my current mode. And anytime I need my current mode, I'll just click this button to get the current mode. So let's look at what we have currently. So there's the, if you are not familiar with VS Code allows you to use plugins to make your development easier. So I'm using live server right here. You can come to the marketplace here. There's a marketplace here, and if I type live server, it should already appear here. So this is it. This is what I'm using to run my HTML document. You can install it on your VS Code to run HTML documents. So I'll run this now with open with live server. Yeah. So this is what I just wrote in HTML, right? This is what I just wrote in HTML. So it's not difficult. HTML is not something difficult. And the Web2 guys just did an introduction to HTML yesterday, right? So it's not something difficult. So this is what I just did with HTML. Now the styling we're supposed to apply CSS, but I don't want to take time writing CSS since the class is not meant for CSS. So I'm just going to come to Learn Web3 DAO and copy the CSS they have here. Where is it? Yeah, so this is CSS they have here. So I'm just going to copy it and paste it in my code. Yeah, so that's the CSS they have. We're going to see. So live server, the reason why I'm using live server is that it automatically updates your code. So any change I make here, it automatically updates on the browser. So I've pasted this and it's going to update what we just had here. So this is it. It updated this, and I'm coming. So I think I made a mistake here. So let me see. Button. Okay. I think this is supposed to be div. Okay, yeah, so I think it looks better now. So the reason why I knew that there was a div here was because I had written this code before. It's not like I just magically knew. I can't just know that there was a div there. I had written it before, so I knew that the issue was there. Was that there was no div there. So that's it. So that's our client basically, and these are the buttons: set mode, get mode. Any particular mode we are in is going to be updated right here. It's going to show right here. The only thing is that when we say set mode, it's going to be updating a smart contract on the blockchain, and when we say get mode, it's going to be getting our current mode from a smart contract on the blockchain. So it's not too difficult, right? So does anybody have any question? Is there any question before we move on to writing the smart contract? No questions. Seems everyone is good. Wow, I didn't expect. I want a question. Does anybody know have a question? Okay, no problem. But can you guys hear me? And I hope I'm not too fast. They always say I'm too fast. Okay, you can hear
Can
me.
hear you.
You can hear me. Nice. Okay, so let's move to writing our smart contracts. So for smart contracts, the easiest place you can write a smart contract is on Remix. It's also an ID like VS Code. The only thing is that this particular VS Code is on my computer. It's on my laptop, so it's installed locally. But with Remix is an online ID. So I'll just type Remix here, and I'll open it for you. So this is where we're going to be writing Solidity, right? All the Solidity we're going to use today for building our smart contract is going to be written here. I had already written the Solidity for this course, but we're going to delete. So this is it. It's simple. It's not something difficult. So we're going to delete this file. Alright, we're going to delete the file, and So our we should note something. Like I said, let's um let's review this. Let's review this. So my mood, there's going to be my mood. My current mood is going to be here. Set mood is going to update my mood. Get mood is going to get my current mood and put it here. Right. So that is what is happening here. It's going to be a simple. While building a simple getter and setter smart contract. Right. So I'm going to you guys are going to direct me on building this smart contract. Is anybody familiar with Remix here? Is anyone familiar with Remix? Shit. Sorry, can you guys hear me? I think my network was cut off. Hello?
We can hear you now. We can hear you now.
Okay, so where did I stop? Does anybody know where I stopped? Like, where did you hear me to?
We just opened this Remix ID online.
Oh, I just opened the Remix ID. Wow. Okay. Let me go back to it. So, like I already mentioned. Sorry, can you put off your mic? Yeah, thanks. Like I already mentioned, the Remix ID is used for building smart contracts using Solidity. So you can write your smart contracts using Solidity. We are using this Remix ID, and that's mostly it about the Remix ID. It's an online ID, so you can access it even on your phone. Right, you can access it even on your phone. Is there a hand up? Yeah. What's up? Oh, sorry. I'm not saying like. Sorry about that. Oh, okay. Can you see my screen?
Yes.
All right. Nice. So this is the Remix ID. It's used for writing smart contracts. You can also use VS Code to write smart contracts. I already used my VS Code to write this HTML. You can also use your VS Code to write a smart contract, but it's I'm using Remix because it's easier. It's easier to use, right? It's easier to use, and for beginners, you are recommended to just use Remix. Then later on, you can move to VS Code and other tools, right? So we're going to be using Remix for this. So that's mainly what I'm going to be using Remix. And so I want to write the Remix contract now. So I want to write the Solidity contract now. What do you think would be a good name for the Solidity contract I want to write? Can anybody suggest? I want to type the name now. A good name. I need suggestions for a name for this smart contract. Any name? What do you say? Mood. Okay, mood.
All right. Tracker, mood contract.
Yeah, no problem. Mood. Let's use mood. 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 So we're going to create a new file called mood. I'm going to create a new file called mood. Soul. Right. So the soul is just like So Solidity files use an extension called SOL. Soul. It's just like the one here, index.html, right? So files have their each language has its own file extension. Index.html for HTML, style.css for CSS, index.js for JS. So .js is there, .css.html, but for Solidity is .sol, right? So it's .sol. And so on Remix, this is an empty Remix stuff. I'm going to have our smart contract in here. So for Remix, if you are starting a Remix application, you have to first declare a license, right? You have to first declare a license. Now a license a license identifier, you have to actually declare a license identifier. A license identifier helps people to know how to actually use your code. I'll explain why. So this is the license identifier, right? SPDX license identifier MIT. Now I'm just giving it a license. I'm just giving it the license identifier of MIT. The reason why people specify a license identifier here is that is because the code is public, basically. So the license identifier helps people to know okay, how am I supposed to use your code that is public? Can I copy it? Can I distribute it? Can I resell it? All those kind of things, right? So that's why there's a license identifier here. It's just you understand how you're supposed to use the code, and most of them are usually open source, meaning you can contribute to them, you can reuse them as you like and all. But some of them are not open source, meaning if you reuse them, that if you use them in a way that does not adhere to what this license says, right? They can charge you to court for using their code either mischievously or against what the license says, right? So because it's usually their code is usually public, they had a license which tells you how they want their code to be used. If you go against that, you can be sued in a law court, right? Not the Nigerian Supreme Court, but in the law court. Yeah, so that's it. That's mostly it. So there's another stuff here called pragma, where you have to specify the compiler version, right? So there's something called pragma. So I'm going to just write it first. Pragma Solidity. If anyone is familiar with Solidity here, can you suggest the compiler version that we should use? Suggest the compiler version. Please be fast.
0.8.13.
13. You have gone far. Have I even used 0.8.13 before? Okay.
0.8.0.
Let's use 13. 13 is fine. 13 is fine. So this compiler version here, right? It's what it does for us is that I'm coming. There's an error here. So I'll have to check. Let me see. Sorry, these are since I've just hold on. Okay. SPDS license has provided in source file before. We should consider adding a comment contain. I can't see this is actually a warning. It's warning me of something, but I just can't see. Okay, I think it's here. Okay, to use SPDS license identifier. Oh, sorry. With my spelling of identifier. I think there's something wrong with my spelling of, yeah, there was something wrong with my spelling of identifier. Yeah, you guys didn't notice that. There's something wrong with my spelling of identifier. So yeah, so that's it. Before I talk about this compiler, we'll be back to this compiler in a bit. I'll talk about this compiler, but we'll be back in a bit. Can you guys hear me? I hope I'm not. Can you guys hear me?
Yes.
Nice. So we're back to this compiler in a bit. So this specifies the compiler version. So but before then, I want to create the contract. I want to just like create the contract body. So what should you call this contract? Any suggestion? Contract. Mood. Okay. So the mood contract. Mood contract. So that's what we're going to call it, mood. Remix now has not given me any errors. If you notice any editing, yeah, you know there's a red stuff here. So this shows that it's an error. I'm having an error here, and it's saying that but it's saying that I'm missing a declaration. But actually, what I'm actually missing is a closing brace. Right, so what I'm actually missing is a closing brace. So anytime you see red stuff on your remix ID, it means there's an error somewhere. Right, so now this is the compiler version. It's compiler version 0.8.13 is what you guys have suggested. So what actually happens is that any code you write here is actually written in a particular language, right? It's written in a language that the actual machine that want to run that code does not understand. So let's say where is my, I hope I'm not taking this is already 6:40. I'm going to give you a demonstration. I think I'll be fast. Let's do this. I hope this is one of my documents. So I want to give you the demonstration. Okay. So I want to give you a demonstration to explain why we need that compiler version, why we need that compiler as a whole. So for the compiler, this is the reason why we need the compiler. Let's say, so we have solidity code. We have the solidity code, and we have the solidity code. Then we have byte code, and we have the machine. So this is what happens. Like your computer, if you notice, if you have ever heard, you should have heard of machine code before. That's the type of code that the machine can run. It does not understand the text that we write. Like machine now, the computer does not understand all this. So what happens is it converts them to bits and runs the zeros and ones. So what it understands are zeros and ones. Like you now, Yoruba. So you have to convert your Yoruba to English for me, so I will understand it perfectly. So that's what is happening here. The machine that is going to run is going to it does only understand call byte code. Alright, it only understands what they call byte code. Can you guys hear me? Since my system is hanging.
Yes, we can hear you.
Alright, so the machine that is going to run the solidity code only understands what is called byte code. Now, what we're writing has to be converted to byte code, and that is what the compiler is doing for us. It compiles our solidity code to byte code so that the machine can run it. So you get what I'm saying? Right, so that's what happens. So the compiler converts the solidity code to byte code so the machine can run it. So that's just it. The byte code itself runs on the machine. So let's go back to our contract and let's see. So first off, I'm going to create a variable to store our mode. Alright, I'm just going to name it a private variable mode private variable mode string mode. Alright. So there's an error here. Cause someone tell me what's happening here. Like, does anyone know why I'm having this error?
You are putting private in front of the name of the type.
Okay, I'm putting private in front of the type. Okay. So our error is gone. Yeah, so that was the issue there. Private was in front of the type. So you have to write variables in Solidity like this: string private mode. So the private tells us that no other contract can read this particular value, right? So any other contract that exists on the blockchain can't read this particular mode value right here, right? So like I said before, if you have any question while I'm writing this, just ask. I'm ready to answer. Ask. You can interrupt me as I'm talking. So that's it. There's the private here, and it tells us that no other contract is going to be able to read this. So we're going to create a function now. Can someone suggest a name for a function for updating this variable? A function for updating this variable, where we can set this particular variable to a value.
Update mode.
Update mode. Oh, that's fine. Update mode is fine. Update mode. Okay. Update mode. So I'm going to make it public. Alright. So update mode is going to be public. And when you're updating the mode, right, like I said before, if you were here at the beginning, when you're updating the mode, right, and that is when you're actually sending a request to the blockchain, you have to tell the blockchain what mode that you want to update to, right? So that what is going to be here is going to take arguments of the new mode that we want, right? So I'm going to write it like this. So let me write it as call data. So we're going to take an argument of the new mode that we want. The reason why I'm writing it as underscore mode here is because if I write it as mode, I'm going to get a warning, right, telling me I'm overshadowing the value of this because the two are named the same thing. So I'm just going to put an underscore there to prevent that warning. Now what is going to happen is that I'm just going to set mode to underscore mode. Where's my underscore? Yeah, so I'm going to set mood to underscore mood. Right, so that's just it about updating the mood. So when you say let's say you're sad before and you change it to grumpy, this is what we're going to call to update that particular mood. So to get our current mood, can anybody suggest a name to get our current mood? A name, any name suggestions?
Get mood.
Get mood. Alright, nice. That's nice. So get mood. Right. So this is going to get our current mood. Since it's just getting a value, it's not actually providing for this particular implementation. Since it's just getting a value, we don't really need any argument here. We don't need to pass anything. What we want a mood. We're not telling it that we want to set a mood. We just want a mood. So we're going to call get mood. So what's going to happen here is I'm going to return. Now we're going to get an error. Just watch. I'm going to return mood, and there's an error there. Now if you read this error, it says different number of arguments in return statement than in returns declaration. So this means that when I'm calling return here, unlike other programming languages, I have to specify what I want to return in the function declaration up here. So I have to say returns something, returns string for this particular implementation, and I have to specify the data location. So I'll just say memory. So and I have to specify data location also. Now there's also a warning here. So it's saying this is not the one. This is just almost everything you write in Ethereum says infinite gas. So you have not heard of gas before. It's like how would I put it? Is the amount is the value you pay for to run transactions on Ethereum. When you send Ethereum to somebody, you pay for gas. That's the fee. That fee that you pay, you're actually paying for gas. Right. So is the value you pay in order to run transactions on Ethereum. So so this is the warning. It says function state mutability can be restricted to view. Now being view helps to put some restrictions on it. It helps to put some I'm not supposed to write it here, it's supposed to be here. It helps to put some restrictions on it to say okay, it means that anytime I call get mode, I can't update the current state of my contract. So it means that if I call get mode here and I'm trying to set modes to underscore mode, it is throw an error because it's a view contract. I'm only supposed to view the state. I'm only supposed to read the state, not write to the state, not update the state. Right? So that is why there's a view here. It helps to prevent some mistakes when I'm writing my code. Right? So if you want to learn more about Solidity, because actually we are done with this contract, right? We're done with this contract. If you want to learn more about Solidity, you can come to the Solidity docs. So there are various resources for learning Solidity. There's this particular resource that we have at Blockchain OAU. I forgot the name. But let me just type Solidity docs here. So I'll give you Solidity docs. So the Solidity docs tells you how to write Solidity. It explains Solidity for you from a fundamental level. And this Solidity docs, even me, I always come back here because Solidity is always improving. Right, so I always come back here to see what's the latest and to catch up on the latest development of Solidity. So I'll paste the docs here for you guys. So that's the current docs, and then so that's it. So we're done with our contract. Right? So I will need to deploy this contract on the blockchain. Alright, like I said before, your smart contract has to run on the blockchain. And what's going to happen is your client, which I've already written here, is our client, is going to interact with that blockchain. So for the blockchain we're going to be deploying this it's called Goeli. If you check the Learn Web3 DAO, this is the Learn Web3 DAO resource we're using. So if you are new, if you just joined, we're actually doing build your first dapp with ethers.js on Learn Web3 DAO. So if you check Learn Web3 DAO, they tell you where you can get funds to pay for gas. Like I earlier said, when you're doing a transaction on Ethereum, you have to pay for gas using funds. So on Ethereum, they have what they call mainnet and testnet. Mainnet is where you do real valued where you spend real valued money, right? Where you spend money that has real value, like the real Ethereum, you spend it on mainnet. in order for you to run transactions. It's spend it on minutes. But there's another value. There's another instance of the blockchain, of the Ethereum blockchain, called the testnet. Right. So that testnet, you can run tests there, and you can use fake Ethereum to run transactions there. So in order to get fake Ethereum on the Web3 DAO Web3 DAO page, they've explained to you how you can get some Ethereum on the Goerli testnet. So we're going to be using the Goerli testnet. They have explained to you how you can get some fake Ethereum. I've already done this, so I already have some fake Ethereum for me. So in order for me to deploy my contract, I need fake Ethereum, because deploying my contract is basically a transaction, so I need to pay for gas. I need fake Ethereum, and I already have that. So I'm going to show you how I'm going to deploy my smart contract now. So for this deployment, I'm going to come here, and I'm going to select injected provider MetaMask. How many of you are familiar with MetaMask wallet? Just raise your hands. Raise your hands in the chat. How many of you are familiar with the MetaMask wallet? No one. No one is familiar with MetaMask here. Okay, you're familiar with MetaMask. That's nice. So MetaMask is a wallet. It's basically a wallet that helps you hold your cryptocurrency. Nice. It helps you hold your cryptocurrency, right? In a sense, right? It helps you hold your cryptocurrency. But what it actually does is it helps you hold your keys and lets you access your cryptocurrency. That lets you sign and create transactions. So that is what the MetaMask wallet does. So I'm going to be deploying my Remix application with the MetaMask wallet. So I'll come here. I already came here before. So I'll come here, and it has already compiled. So you see it has already compiled here. So because it has compiled, right, that is why I have this. If it didn't compile, I won't have this. So it has already compiled, and I've set it to auto compile before. So I'll just come here, and I already selected MetaMask as the wallet I want to use in deploying. And in my MetaMask, I selected the network called Goerli. So just hold on. The MetaMask extension sometimes takes time to come up. So if you're not familiar with MetaMask, Web3 DAO has already shown you how you can install MetaMask on your system. So this is my fake Ethereum Goerli it. So this is my fake Ethereum 0.6829 Goerli it. So this is the fake Ethereum I'm going to be using in running this transaction. And I've already selected the Goerli testnet. There are many testnets here. We're going to be using Goerli. So this is Goerli, and I've selected it, and I've connected my Remix to my MetaMask wallet. So what I'm just going to do now is I'm going to deploy. So it's just loading. I'm going to deploy this contract right now. So I'll just confirm. So it's just going to take some time. Like it just take some time to complete the transaction. So when the transaction is done, we're going to get a. So it's actually done already. We're going to get a. But MetaMask is lagging, it's showing pending. So we're going to get an address. So this is the address of our smart contract. Our smart contracts are successfully been deployed, right? And we got an address. So this is the address of our smart contract here. This is it. So if I copy this, I can come here and paste it. So this is the address of our smart contract, right? Let me remove this stuff here. Right, so this is the address of our smart contract. This is it. So this is where our smart contract was deployed to. This address shows us where on the Goerli Ethereum blockchain our smart contract was deployed. We need this particular address in order to communicate with the smart contract. This address is almost the same thing as when you want to go to google.com, right? When you type google.com on your web address, on the web address input box on your browser in order to access google.com, right? So that is almost the same thing as this. You need to access my smart contract. I need this of the smart contract, right? So it's just the same thing. That's why you need the URL of different websites in order to access them. So just the same way you need the URL of different websites to access them, the same way you need the address of your smart contract in order to access your smart contract. So I'm going to copy this. I'm going to save it. We're going to need it when we're interacting with our smart contract. Now, right now, this is it. This is smart contract route. We're going to calling update mode to update our mode, and get mode to create our current mode, right? So this is the smart contract I've written, and I've said that it has been deployed on the Goerli testnet, right? So the Goerli testnet is where it has been deployed, and I got this address when I deployed it. These are some functions you can actually call directly on Remix, right? Instead of using the client to interact with the smart contract, you can call it directly on Remix, but you can come here on your own to just like test everything out. So but just to give an example, let's say I want to update my mood now. Let's say I'm sad. I'll update it to sad, right? Okay, I'll update my mood to sad. So just hold on, I need to run the transaction. MetaMask takes time to load, so sometimes. So if you have any questions, you can ask. I'm really expecting questions. I don't expect this to be easy, especially if you're doing it for the first time. So confirm, and I call get mode. So me calling get mode now, right, is basically, yeah, you see this, it has updated to sad just because I set it as sad here. So I updated my mood to sad, and when I call get mode, it tells me that I'm currently sad. Right, so that's it about Remix. Remix allows you to deploy smart contracts and interact with them on the Remix ID. So you can try out the Remix ID on your free time. You should try it out. You really should do it. So that's it about that. Now, this is our smart contract and one of our clients. We need to connect two of them together, right? So that anytime we update our mode, it shows up here. Anytime we want to get our current mode, we can put it here. And anytime we want to update our mode, we type it in here and just press set mode, and it updates. Sure you get. Anytime we want to get our current mode, press get mode, and we see our current mode here. So let's link the two entities together. That is our client and our smart contract. We're going to link the two of them together now. So back to our client. So our client needs to be able to communicate with our smart contract. So I'm going to do that in something called in a script tag. Right, I'm going to do it in a script tag. So this script tag now is where we're going to write the logic for our UI, which is our client, to interact with our smart contracts. Now, first of all, we're going to start with creating the contract. Right, I'm going to start creating the contract. Now, let's go. So for the contract, can someone suggest a name we're using? Like, can someone suggest a contract name? Suggest the contract name we want to a variable name we assign to our contract. Hello, is anybody here? Hello.
Hello, sir.
Yeah. I want someone to suggest a variable name we can use for creating our contract.
Let's use my contract, sir.
My contract. Okay, that's fine. So my contract is going to be equals to something. All right, it's supposed to be equals to something. Now here's the thing. For contracts, for the blockchain and all, there's a way you can interact with the blockchain directly on your own. Right, you can interact with it on your own, but there are things that are called libraries that have been created to enable us interact with the blockchain fast. So they are like pieces of code or bundles of code that have been created, right, by other developers for developers in order to achieve different tasks, development tasks they want to do faster. Right, so libraries are things that people use a lot, and for this particular implementation, we're going to be using something called Ethers.js library. So for Ethers.js, it's a library that allows you to be able to communicate with a smart contract on the blockchain. So I'm going to come here and okay, no, I need this address. Okay, I have the address on Remix, so that's fine. So I'm going to let's look for Ethers.js library. Ethers.js. So this is ethers.js. Alright, so this is ethers.js. Okay, this is 7 o'clock. Of don't worry, I hope we won't get up to stay up to 7:30. So yeah, so this is ethers.js, and we're going to enter the documentation to just find out how we can use ethers.js to communicate with the blockchain. So this is the ethers.js library aims to be a complete and compact library for interacting with the Ethereum blockchain and its ecosystem, right? So it allows us to be able to use our clients to interact with the blockchain, right? So that's what it does basically. Now I'm getting started because this is what I want to do. I basically want to use it. So installing import this was Node.js, but we're actually doing it on the web browser. So this section we need. So this web browser section is what you actually need, and I'm going to copy this one. I'm going to use this one. There's also an alternative of using this one, but I'm not going to use it just because like they are different. The reason why I don't want to use it is because I want to just show you like how you do it on how you create this client in such a way that it will be compatible with almost any browser, right? For this particular one, this ES6 in the browser is a version of JavaScript which I'm quite sure is not supported by every single browser that exists currently, but we'll have a better chance of ES3 being supported by almost every browser. So yeah, so that's why I'm picking this. So we're going to use this one. So to add that library to our client, we're going to paste the script tag here. so we've pasted the script tag here now. So that means that we have access to something called the ethers object. So I'll just comment this out. So if I come back to my first dapp and I come to the console, right, I now have something. I now have access. I now have access to something called ethers. So this is it. So that is it. It's ethers. So if I come back here and I comment this out, it reloads. So it has loaded, and if I come back here and type ethers, it's not there. Like, so oh sorry, this underscore ethers was actually I think this one was put in by MetaMask. So this was put in by MetaMask. If I were to remove MetaMask, I'm quite sure this ethers won't be there anymore. So this is underscore ethers, but this is not the one we installed. This is something completely different. This is not the one we installed. So the one we are actually installing, which will have which will have access to when I uncomment this, is ethers, not underscore ethers. So if this reloads, let this reload, I now have access to ethers again. So this is it. I now have my access to ethers again. So I can use ethers now in my client because I've included it using this script tag. So let's go to creating the contract. Now with ethers, we have, if you're using the library, you have to check the documentation to see how they actually use that library. So I'll come to ethers and see, I'll look for the parts for creating a contract and see how they actually create a contract. So called contracts. Oh, let's not go deep in there. I think the installing part shows us the way we can actually create contracts, right? Okay. Okay. Let's come here. Let's see. Listening for event. I need. Okay. Yeah. Let's use this one. Contract interaction. Creating contract instances. So this is it. In order for me to create a contract, right? In order for me to create a contract, I need to run this using ethers. So I'll say new ethers.contract, pass that address that I told you about, pass an ABI. I've not mentioned ABI, so I'll talk about it soon. And I'll pass something called the signer provider. So let's do that. So I'll write new ethers.contract, right? Then the first thing it says is I'm going to pass an address. Sorry. The first thing it says is I'm going to pass an address. So I'm going to just paste my address in there. So that's my address. And so that's the address of the contract that we just deployed, right? So in order for you to create a contract, like I said, you have to pass an address. Now there's also something called an ABI, right? So the full meaning of ABI is application binary interface. An ABI is something, if you are familiar with something APIs, right? Those are application programming interface, right? So that's what an API is, an application programming interface. If we come back to our slide here, we see this traditional application now. The reason why this client is able to communicate with this server, like the reason why it's able to send a request to this server, is because it's following the standard already laid out by the server. And that standard, you can get it using the API that the server gives the client. So what I'm trying to say is that when the client is sending a request to the server, the API tells it, okay, in this request that you want to send, you can put a name, you cannot put a name, you can add a number, you can't add a number. So the API helps to tell the client, this is the structure of the request that I want, right? This is where you can send the request to, right, and things like that. So that's what the API does. So it's just the same thing as an ABI here, right? So the API helps to tell this client that, okay, these are the things that you can call on the smart contract. This is what you can pass to the smart contract. This is what you can't pass, right? Things like that. So that's what the ABI basically does. So for the ABI now, I'm going to copy it from Remix. So that's not what the Remix we're using. So this is what we're using. I'm going to copy it from here, and so I can get my ABI when I come here. So this is ABI for this particular contract. I'll just copy my ABI. I'm supposed to paste it here, but in order to make things easier to read, I'm just going to say const my contract ABI is equals to, right. So this is our ABI. And if you notice something, if you look at this ABI, well, there's something called the name of the function. So sorry, the type is the ABI is like an array, and it has in this array has different elements, and each element states helps to define what the client can use the smart contract for. So for this part now, the type for this particular element, it's telling us that the type is a function, right? The state mutability is non-payable, meaning you can't set Ethereum to this function, and the name of this function is update mode, right? This is update mode. Remember that when we're writing our smart contract, the name of the function we created was update mode. So that's it. And update mode now can take in an input, right, of type string, right? The type of this input is string. There's another thing called internal type, but we'll just ignore it for now. So the type of this input that is going to take is a string, and the name of this input on the contract is underscore mode, like already defined here. The type is underscore mode, and the name of the argument we're going to be sending is underscore mode, and the type is a string, right? So those are the inputs. And if you come here, there is no output, right? There's no output. But here now, we know we said get mode is when we call get mode, we are getting our current mode, meaning there's going to be an output, right? So there's going to be an output for get mode. So if I come to the ABI section for get mode, in the output it says that it's going to send us an output, and it's going to be of type string. We didn't give this output a name, so that is where the type is going to be string. We didn't give it a name, so that's why there is no name here. So that's basically it about our ABI. So the ABI tells us that we can call update mode and we have to pass a string, and it's telling us that if we call get mode, we are going to get an output, which is going to be our current mode. So things like that. It helps to tell us how to structure our request, and it tells us the type of response we're going to get back, right? So that's it. So you have to interact. The contract needs the ABI, then also needs something called a provider. If you come back here, it also needs a provider for instantiation, right? Now this sign out provider is basically something, how would I put it? So the sign out provider is something that helps to take our request and send it to the blockchain, right? So it helps to take our request and send it to the blockchain. So it holds different properties basically, which includes the URL it includes something like the URL that we're actually sending our request to, right? So the signer or provider are actually two different things. The only difference is that for the signer, you can do write transactions, right? You can update the blockchain state using a signer, right? But you can't do that with a provider. With a provider, you can actually only read state. If you want to update the state, you have to use a signer, because the signer will sign. Actually, I need to sign that transaction to show that it is a valid transaction, to show that okay, this transaction is actually coming from an address. I know what I'm saying is might sound difficult to understand, but just bear with me. You can come back later to listen to the video. We'll upload it on YouTube just for you guys. So yeah, so we need a signer or provider. And to get a signer or provider, if you come back to creating, if you come back to installing, getting, if you come back to getting started, they tell us how to interact. So this is, they tell us connecting to Ethereum using MetaMask. So I'll come here and you will see that they've told us how to create a provider and a signer. So I'm going to use this, right, to create a provider and a signer. But what I actually need is a signer. So I will actually be creating a signer. So let's get down to creating a signer. Right, so they've already told us that in order for us to create a signer, we can just call new.providers.web3 provider window.ethereum. Right, we can call it, but you have to have MetaMask installed in order for you to have access to this particular stuff here. Right, so I can just copy this and paste it. I can actually copy it, and then let me just copy it and paste it in here. I can copy it and paste it here. So let's do that here, because since I'll need the signer here, that means I'll have to create it up here somehow. Right, so I can just say const no, I already copied it, so I can just paste it. So I already copied it, I can paste it right here. So with this window.ethereum is a value that is provided to us by MetaMask. Right, it's a value that is provided to us by MetaMask. So if I come to my first dapp and I say window.ethereum, you see it's there, it's a value that is there. But if I come to let's say I create a new incognito tab and I say so there's no MetaMask installed in this tab. So if I come here and I say window.ethereum, there's nothing there, it's undefined basically, because there's no MetaMask there. So MetaMask gives us that value, right? So what we're actually doing here, is that we're connecting our Ethers library to MetaMask, because we have this window.ethereum in our browser. So what we're actually doing is we're connecting our Ethers library to MetaMask, and it's giving us something called a provider. But what we actually need is a signer, right? So in order for us to get access to this signer, we need to first get access to the accounts in MetaMask. So where is it? Yeah, this is it. So we need to first get access to the accounts in MetaMask. So they said MetaMask requires requesting permission to connect users' accounts. So when I get this account, I'm now going to create a signer using one of these accounts. I'm going to request one account, then I'll create a signer using one of these accounts. So first of all, we're going to do this. Alright, we're going to do this in order to get an account. So I'm going to do it. I can just copy it. But I think I'll pass. Let me just write it. So I'll say account is equals to await provider. Sorry, so provider dot send. So the send is going to be @_request accounts. Right, so what's going to happen here is that this thing is going to give me a list of accounts, right? So I'm going to just log it for us here. So we're going to see the accounts that we're going to get from MetaMask. We are requesting that MetaMask gives us a list of accounts, an array of accounts, and it's going to give us the array of accounts. So when you actually call provider to send @request account, what you are doing is that you are telling MetaMask that you want to connect. That way you're telling MetaMask. So if I run this now, just watch. I can use await. It says I can use await. It says I change I think if I change type, was it module? Let's see. Okay. Alright, so for some reason I can't use await. I thought I was going to be able to use await here. So we're going to have to use promises.
Sorry, can I say something?
Sure.
I think you can only basically use await in an async function. So see what you have there now. any async function that can maybe perform to use an await, right?
Yeah, sure, sure,
So that is
sure, definitely. But there's this there's this function of it's only valid in async functions and the top level bodies of modules. Sure you get. So they say it's valid in async
yeah.
functions. I'm aware of that. But he also says that it's valid at the top level bodies of modules. Mean I'm supposed to be able to use await here if I can. I think it's type module. If I can change this to type module, I think I'm coming. Let me confirm from learn web3 DAO. Yeah, learn web3 DAO. I know they used await. Um, I know they used await here. Um, where is their script? Huh. Their script tag is supposed to create a new Solidity file remix, specify Solidity version, deploy, get mode, set mode. Wait, so this is deploy, control deploy. Okay, so type script. They didn't add anything to their script tags. They didn't add anything to their script tags. So I wonder why they didn't add. Okay, I think it's working now. Just hold on. Yeah, it's working now. Yes, it's working now. What was happening before? It's working now. Let me cancel this. Cancel. Oh, why is it not canceling? I'm rejecting. Oh, sorry. I rejected, but I think it's reloading. So yeah, it's working now. So by specifying type equals module, I was able to use await here, right? But normally you're supposed to be able to use it in async functions, but because I'm using it in a browser, I'm able to specify type equals module. I'm able to use await. But we should also note that not all browsers support this, right? So if you are building an application for a lot of people, right? You can't use this. You have to use promises. So yes, so this is it. When I say await provider to send Ethereum underscore request account, I'm going to be telling MetaMask that I want to connect to MetaMask. So if I reload this, cancel this thing for me. I don't know why that thing is not canceling. It's supposed to. Let me remove this thing. Yeah. Okay, I rejected it. Yes, I want to reject it. Now, if I reload this, it's going to tell me that I need to connect to MetaMask. You see that, right? So it's going to tell me that I need to connect to MetaMask, and so I'm going to let it connect to this account because this is where I have Goeli Ethereum. So I just press next and connect. Right. So it's request. Why is it requesting again? So you just hold on. Files and so it says account is not defined.
let's see your error message. Let's see the error message.
Yeah, it said account is not defined. This is it. It says account is not
Yeah,
defined.
that's good.
So provider to send it underscore request account. Oh, sorry, this was a typo. So that was a typo actually. So if I let me remove this. I've been making a lot of typos and you guys have not been noticing. Alright, so yeah, I'll be able to log this account here, right? Because I connected to MetaMask before. So if you remember that I connected to MetaMask before when the page reloaded. Right, so when I logged it here, it's logged, right? So there was a typo here, that was why I was having that error before. So console log accounts, right? And this is the account that we currently have. Now in order for me to create a signer, I'll just say const signer equals what was it? I think this provider would get signer and I'll pass in the accounts that I want to connect with, that I want to be a signer. So I'll log this first to see the signer. Or is there a need? Oh, our time is fast spent, but I think I can just show the signer. Alright. Yeah, so this is our signer. There are different types of signer. This is a GC and a BC signer. You can check it Ether's documentation. They have a lot of stuff for you to learn, and this is really sweet, to be honest. So yeah, so this is our signer, and since we have our signer, it means our contract is ready to go. So let's get on with creating our contract. So I'll just put the signer in here. I'll remove this log. I need to give space in order to make the code readable. Yeah, so this is our signer, and I've created our contract. So my contract now is a contract. It was created as etas, new etas as contract. Pass the address, pass the contract ABI, pass the signer. So I have my contract right here. Now moving on, what did we say we want to do? We said we want to be able to set mode and get mode, right? That's what we said we want to be able to do. Now we already said that all these things are available in our contract, so we need to be able to call anytime we need to be able to do it such that anytime we click on set mode, it will call our contract set mode function here. It will call, oh sorry, this is set mode. Okay, yeah, it will call anytime we click on set mode, it's going to call update mode here. And remember we named it update mode. So anytime we click on set mode there, it's going to call it update mode here. And anytime we click on get mode, it's going to call get mode here. So this is going to return our current mode, and this is going to set our mode. So let's link it up and connect the two of them. So I'm going to show you how we're going to do it now. So first off, I'll just create a function called get mode. Sorry, yeah, let's call it get mode. I think get mode is fine. Function get mode, and so it's going to be get mode. And what it's going to do is that we're going to call my contract dot, remember we already created a function called get mode with it. Alright, so just my contract dot get mode. Alright, so it's as simple as that. I'll just call my contract dot get mode, and this should be an async function because I'm going to use await inside here. So it will be my mode is equals to await my contract dot get mode. Oh sorry, I think it's not supposed to be here. I think it's meant to be here. So it's going to be because mode equals await my contract dot get mode, and it's going to return my mode. So I'm just going to log it. And if you remember, our mode then was we're sad basically. That was our mode, right? We're sad. So if I come back here and I reload it. Okay, sorry, I'm supposed to call this function. This is a function, so it has to be called, right? So I have to link this get mode with this button, with this button that we created before. So in linking it, I'll just say on click is equals get mode. On click is equals get mode. So anytime I click on get mode, it's going to call this function. It's going to give us our mode. So just pay attention as we call get mode now. So if I call get mode, so you see get mode is not defined. Oh, I must have made an error. There's no error here. So how come it's saying get mode is not defined? Sorry, everything reload. Okay, so it's still saying get mode is not defined. How come it's get mode not defined?
Okay, for what I'm saying now, right? Let me see your get mode function. Yes, same function you have. Okay, now you called my contract dot get mode. So it's like a closure. So I don't know this. Just go back. Yeah, from this part now you have const mode is equals to await my contract dot get mode, right? You are just calling the get mode. I didn't say you defined like where you defined especially the get mode, and you probably passed a parameter and you say it as what's going, since it's going to be a get mode function, you meant to return a value. So I didn't say you didn't define it separately before you called it inside this get mode function. So I feel that for us to have it work out, you have to have a separate function for the get mode. Then you pass either a uint value for it. If you're going to return an integer, a string, or whatever you're going to return, then once it has returned it, you now call it inside here together with my contract. That's where you're going to probably work out. So since you didn't define it before calling it inside a very function, I'm not seeing the possibility of it working, something like that.
Okay, yes. So what you're saying now is that I didn't define get mode before I called it.
No, not that, not directly. function get mode. I mean, the get mode.
Mm-hmm. Sorry, just hold on. I want to see something. So
But
you see,
it's
it's
like,
not defined.
sorry, sir.
Yeah, I'm listening. I'm
It's
listening.
like yeah, it's like you defined the function mode, but you didn't return it.
Where? Where was that?
That gets mode function.
Which line? Which line? Tell me the line.
Line 70.
70. Yeah. I'm not supposed to return anything. I'm logging it here. I want us to see. I want us to see the value that it returns. Sure, you get what I'm saying? So I'm logging it here.
Okay.
You get what I'm saying? Right. So, sorry, yo. Can you put up your mic? Yeah. Thanks. So basically, the issue I'm having now is that when I click on get mode, it says get mode is not defined. Alright. I think for some reason, I don't know why that's working like that, but
Okay, and first off, if I should ask, right, this get mode, what was in
I can't hear you, bro. Hello, someone talking.
meant? I just came in. You get me, please?
Sorry,
Hello.
was I off or it was you? I didn't hear what you said. What did you
I
say?
wasn't. Okay, can you hear me now?
Yeah, I can hear you now. What did you say?
I said this get mode function, right?
Mm-hmm.
What exactly is it performing? Like, what task is it performing basically?
So you're supposed to get a mood. You're
The
supposed to
mode,
get a
right?
mood, yeah.
Okay. So now, for it to get a mode, I believe the mode is meant to get is one will pass on the front end, right?
No, don't worry. We're not passing any mood to the front end. We're just calling a contract to return a mood.
Okay. I'm seeing the button. I'm seeing on click button. Okay.
Where is my own click? Okay. So let me give it a class of get mode. So I'm trying to see what exactly is the error here. Why is this one coming up? So let me assign so what was the class I gave it? Get mode. Sorry. Get mode. Document of creation to get mode dot add event listener click. So it's going to run get mode. I want to see if this works. So let me just log something here. No gibberish, and let's see. So this is my first tab. So that works fine. So let's see. For some reason, I don't know why that other one was not working. So we'll just run everything like this. So this is get mode, and I'm going to be using promises now. I think I'll have to use I think I can still use asynchronous. I should still be able to use asynchronous. Yeah. So I just say const mode is equals to await contract. So my contract, right? My contract dot get mode, and I'll just log our mode. Yeah. So this should work now. It's still loading. Let's reload. So that's our mode, right? So that's our current mode. We are currently sad, and if you remember, we set up our current mode as sad. Here, where is it? We set up our current mode as where was it? Okay, yeah, it was here. Yeah, if you notice, we set it up as sad. Let's say I change this to happy. Let's say I change it to happy. So I've changed it to happy now, and if I call, okay, it's still updating, so it's still pending. This is pending, so this is going to, when this completes, you will see it right here. I've taken a lot of time. That's the thing about live coding sessions. Like in live coding sessions, they always, you can't really, you shall experience one bug or the other. Yeah, so if I call get mode now, this is meant to change to happy, right? It has changed to happy here. Now if I come back to our if I come back here, this is going to change to happy. You're going to get up. I'm going to get happy there now. So this is happy, right? And we're good. So that's our current mood. Now the next thing is for us to put our current mood right here. And to do that, sorry I'm being fast. To do that, we'll just say we'll select it. Where was it? My mood. So we'll just say document dot query selector h2 dot text content is equals to my mood. Okay, I like template literals, but let's just use let's use this concatenation. So my mood is going to be that mood. So I'll just come here and right, so if I call get mood now, I'm happy. That's my mood. So my mood is currently happy. So I'm currently happy. And let's go ahead with set mood. Sorry, it's taking time. Set mood. So if I have bugs can come up at any time. So set mood. Let's set up our mood. So to do set mood now, we have to also create a function called set mood. Sorry, there's something on my spelling. So we'll create a function called set mode, and it's going to be const no, don't worry. So what we're going to happen here is that we're actually going to be passing any mood that we enter here. The mood that we currently enter here, right, is what we're going to be setting as our current mood. Alright, so what's going to happen is, for this set mode, I will have to get the value that is currently in the input. Alright, so I can just say let me use this one. I'm trying to copy document or query selector because I need that input, so I need to access the input. So I'll just say document or query selector input dot value. So const mode is equals to, so this is my current mode. Once I get my current mode, I'll just come down here and I'll say my contract. So it's going to be await my contract dot update mode. If you remember, we set our function to update mode, so it's going to be my contract dot update mode, and we're going to pass in the mode that I want to update it to. That's just it. Now to know when the mode has been updated, we'll just okay, there's a way ethers just .js works, right? What it actually returns here is a transaction, something called a transaction response. So we'll just say transaction response is equals, you can check the documentation, right? So you can check the documentation for what I'm actually writing now. So it's just going to be transaction response. So I'm going to do await transaction response dot wait. So all these I'm writing are currently in the ethers.js documentation. So that's transaction response dot wait. So what happens here is we're going to wait for the transaction to be complete first. What this returns, when this returns is that it returns when the transaction has been sent to the blockchain. The transaction being sent to the blockchain does not mean that the transaction is complete. The transaction is only complete, right, when it has been mined. So when Ethereum 9, we don't mine anymore. So when the transaction has been validated by the validators on the POS network, you can leave all that gibberish, right? So but when the transaction has basically been mined, right, that was when transaction is complete. So if I call await transaction response of wait, that's when transaction has been complete, and that's when it has been mined. So I'll just call it and I'll just put an alert here. Alert what do I alert it to now? Let's say mood set. So if I set our current mood to grumpy if I set it as grumpy and I call set mood, alright. So it's supposed to give. Oh, sorry, I've not assigned. I'm supposed to assign this set mode to this button right here, alright. So I'm going to give it a class of set mode, and I'm going to come down here and copy this, then I'll call set mode, and I'll click, and I'm going to call set mode. Alright, so I'll come back here, reloads, and I call set mode. So I'm setting our mood now. So I'm going to send a transaction on. Sorry, leave this. So I'm going to send a transaction on MetaMask. Alright, so when the transaction is done, we're going to see an alert here telling us that the mood has been set. Alright, so on did I set it? Did I enter a value in this input box just now? Can anybody hear me?
No value.
No, you just
I didn't enter a value. Wow. Sorry. I'll need to redo that stuff again. Let me enter it as grumpy now. So I'll call set mode. Confirm. I was doing this one. Confirm. So this was the former mode. This is not the current mode that we just. So this one is going now. So this was the former one that I just called mode set. This one is going now. So if I call get mode, you see it's going to give us our former mode. What was happening? Did I change? Oh yeah, okay, alright. So the current mode is now grumpy. You saw that, right? Hello, can you guys hear me?
Yeah, I can hear you.
Yeah.
So can you give me a mood? Let's do one last time. Give me a mood. Give me a mood. Which mood do you want us to currently be on?
Cover mode.
Sorry, I can't hear you guys. What did you say? Hello?
It's one and 10 modes.
I didn't get that. Sorry.
You're asking for a mode to call, right?
Yeah, a mood. I need a mood.
Excited.
Okay. So a mood. I'm going to set our mood as excited and So our mood has been set, and if I call get mode, this button is not clicking. Yeah, change to excited. You saw that, right? So that's it. We're done. That's our dapp, basically. Sorry for that bug, but it's normal. It's normal. So yeah. So that's our dapp basically. We started with writing this client. Where is the client? Yeah, we started writing this client, my first dapp. We wrote the HTML and the CSS. We actually copy and pasted the CSS, but we actually wrote the HTML ourselves, right? Then after doing the client, we came here and we created our smart contract. It's a very simple smart contract, right? It updates a mode and it gets a mode. Alright, so that's just it. These are mode, updates it and gets it. And I told you that this is Remix, and I told you that you can interact with your smart contract using Remix. And if you come here and you call get mode, you see that it's currently excited, right? So this was the mode we set earlier in our client, so it's now excited. So this is smart contract. When we were done writing the smart contract, we came back here and we created our smart contract. Where's our smart contract? Yeah, we created our contract here. We passed in the address, which is the address that was deployed on. We passed in the ABI, we passed in the signer, right? For all these details, you can come to ethers.js just to see how this is ethers.js, just to see how all these things actually work, right? Now let me paste it here. So that's ethers.js, just in case you're interested in ethers.js. So we created our contracts, passed in the ABI, passed in the signer, and we created our functions get mode and set mode. So get mode returns. Get mode gets our current mode and puts it in the HTML document. Set mode gets our current mode from. Set mode sets our current mode to a new value, which we enter in the input box here, the input element here. So That's basically it. I knew this. I know this took a lot of time, but yeah, I hope you guys learned a thing or two. And thanks for coming. Really appreciate it. If you have any questions, just go ahead. Go ahead with your questions if you have any.
Okay, I want to say something.
Yeah.
Please refer back to the contract you had.
Okay.
Sorry, not the contract, the scripts. Your
Okay.
scripts. Yeah,
Yeah.
yeah,
Yeah.
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 No. Okay. You had the out TS response, right?
Yes. Yes. Are you talking about this one?
Uh,
Which one are you
you-
talking about?
you
Okay,
have
this
the
one. Yeah.
line.
Yeah.
Yeah, yeah. So it didn't indicate how many blocks you're meant to wait. Just because that means I don't think that very one did anything specifically, but it didn't include the amount of blocks. Whether you want to wait for one block, two block to pass before we can be able to confirm that our TX actually went through, right?
Okay.
So I don't know if
Okay.
it's
Yeah.
working that way.
It's
Like,
fine. It's fine. So this is it basically. This defaults to one block. If you check the documentation, where is it? I think it's in contract interaction. If you check the documentation, I'll show you now. It defaults. It should default to one block. Where is contract interaction?
one block.
Yeah. Where is it? Creating instances. So methods. Let's see. So this is right.
Yes,
This is right analysis and transaction response. So this is transaction response, and this is wait. So this is it. You see this? So this means it
Yeah.
defaults to one block. So you get.
one block.
Yeah, so it defaults to one block. So it waits for one block to be mined. So you have, like you said, you can set it to any number of blocks you want. So it waits for one block to be mined and sends an alert basically. Yeah, so it defaults to one block. Nothing doesn't. So thanks for that question. Any other one? Any other one? I'm here to answer your questions. It's like you guys really got this thing. Personally, I know I won't get it. Yeah, what's up? What's your question?
Like I don't know if it's just for me or like the whole stuff, the syntax, especially for the solidity when we went to remix, I think it's kind of like Java syntax.
Yeah, yeah.
Because of the memory and the rest of it. I think we don't have any question now because we don't really get it. But I think with time, we'll just understand it. Maybe once we go through it this week, by this first part now, if we can go through it this week, before next week, I think most of us we have one or two things to pick from it. Even without the whole stuff, we still have one or two things we got from it.
Nice. That's nice. That's really nice. So just to note, when you want to start, just come to learnweb3.io. Like they explain everything you need right here, starting from intro to programming, what is a blockchain, what does everything you need to hear. It's like it's like they just handed you a platter of, I don't know how to say it, a platter of gold for you to learn. So you shouldn't dull, just pick it up and you'll be fine, right? You'll be great. And if you have any questions, just ask on the group. Sorry, who was asking me the question just now about the transaction response wait block? Who was asking?
The one.
Oh yeah, the one, Avi. What was your who are you on the group? What was your name on the group? Can you send me a message?
Chelna.
You can send me a message.
I don't know.
Can you send me a message like DM? Can you send me a DM?
WhatsApp, right?
Yeah, WhatsApp. You know me on the group, right?
Not really. I just said your name. So
Yeah. Now me they talk pass. Now me they blab pass for that side. I beg no face. Yeah. Now me they talk pass. Anyway, yeah, that's it. So if there is no other question, which I'm assuming there is no other question, please do this. And when you are done basically, or when you are going through it, if you have any question, ask on the group. Uche now we answer you because me I don't tire. But anyway, we answer you. One the other guy is there, and Ayola is here too. Benga is here, so he will answer you. Blessing is there. A lot of people are there. So please, if you have any question, right? Any question at all. I really want you guys to ask questions. But if you have any at any time, just go on the group, put it there, and you will get it. We'll get it answered. We must get it answered, right? So I hope you guys enjoyed this session. Thanks a lot for coming. We'll upload the video soon. It should be up by tomorrow, and we'll send the link to the group. So thanks. I think we're done here. Right. So
Thank you,
thanks,
boss.
yeah. So we'll meet next week.
I'm not going. Hope you're going to post the code to your GitHub, right? Like
The code. I actually okay. I was not actually thinking about this code. Like I was thinking, but no problem. We'll post it. Maybe I'll send it.
And yeah, and again, I want to suggest maybe just include comments at some point, right? So for some person that might be watching the video, yeah, so they can also recollect via the comments to help them to know, okay, this is this in case they forget.
Okay.
Like that.
Nice. Thanks for that suggestion. I'll do that. Surely. So thanks, guys. We'll see you next week. We'll see you on the group too. So any questions you have?
Okay.
Yeah. Thanks. Bye. Oh wait, hold on. Opeyemi, you have a question. What's up? What's your question? Opeyemi, you have a question. Can you speak? Or you just raised your hand by mistake? Okay. Opeyemi, okay, I don't think he can speak, or maybe there's something wrong, or maybe it was a mistake. Alright, I think we're good. So next week we'll meet. Next week we'll meet. And if you have any question, Opeyemi, can you hear me? If you have any question, just ask on the group. Right. So thanks a lot, guys. Bye.